So today we have this work light to look at. This is ANCEL SQ129 work light, and they were gracious enough to send us this light to look at, see what we thought of it. So today we'll just see the features and see the inside parts of this work light. USB-C, that's a good sign already. Even though I'm a small channel, I do get asked a lot to review and look at things, and I very rarely accept things, but if I do think they're interesting or something I would buy myself, if I do find it that interesting, I will agree to it on the terms, of course, that they let us look inside and just give an honest review and opinion of it. Here's the user's manual. We'll do a quick review of it. 4400 milliamp hour, 4.4 amp hour, 6200K, color temperature, 1200 lumens, light modes, anywhere from 4 to 15 hours of runtime, and 5 volts output. That's at 1.5 amp even for a battery bank. That's pretty cool. I'll let you look over the user's manual here, and you can pause it if you would like to look at it any further. Here's a few of the features and specs on it if you're interested. So we cut it on and it comes on full bright on both. If we hit the button again, it goes to dim mode, and then it goes to, well, even brighter. It alternates brighter modes on each one as you push the button again. So yeah, if you go to individual, it's actually brighter than they are together on the first mode when you turn it on. Very versatile heads here. You can move these in a lot of different directions. I do like the idea of it. I know I'm washing out the camera here, just trying to give you an idea of the features. So that's more like a flashlight or spotlight if you hold the button down. If you press it again, it goes into like a SOS mode, which I'm not the craziest about, but I guess you got it if you need it, right? I really like it as a work light, though. I like how bright it is and how versatile it needs to adjust the angle is, as well as the many mounting ways, which we'll get into in just a minute. So yeah, we have our tripod mount. We also have 4, it looks like pretty strong magnets. Let's test that out. Yeah, that's actually a lot stronger than I even thought it was going to be. You won't have no trouble with that falling off. Awesome. You got your hook as well. You can hook it somewhere if you needed to. Let it hang. So here where we have our USB-C input for charging, and we have our USB output as a power bank. And without wasting any more time, let's look inside this thing. So as we get into this thing, these are silicone leads on the wires. That's super flexible, and that's nice, especially as these move back and forth a lot, so I do like that. There's our tripod mount. That's actually pretty heavy duty. Machined aluminum block here. A little flap. So this must be a battery. Yeah, we got a battery and looks like a board in here as well. So there's 2 boards. Must be the battery management board. So I'll give you a close-up of this battery here. This is 18650, 4400 milliamp hours. Nominal 3.7 volts. I really do like how modular this is. Look, it unplugs really easy. That's the battery. That's like our on-off control board. Our 2 LED lamps unplug independently. That's really cool. As we look at this board, we got some small transistors, and we have a chip, some LEDs for indication. We have, and I don't see anything on this IC. But gotta be a microcontroller, but I do not see any writing at all on it, so don't know. Let's go ahead and get this board off while we're taking it apart and just take a good look at it. It's probably nothing but a push button on the back, but hey, while we're looking at it, let's double check. Yeah, just a push button, but now it is a pretty nice push button. Surprisingly clunky for a little push button. I do like it. We see our USB-C jack and our USB jack for our power bank. As we look at these chips here, we got two little 8-pin chips. We have a CL4056A, which is a 1 amp battery management chip, and we also have a SP4533, which is a DC to DC converter chip, hence the inductor right below it. So that is what's doing our DC to DC converter to give us our output. Obviously, as we see to the left, to the output pin of the USB for the power bank. Pretty straightforward. I don't think that's nothing but a spacer. Yeah, we'll just go ahead and put this board back in, then we'll get on with some testing. I do have a new DL24 load tester or load meter capacity tester that I want to check out with this light as well. The hook does come off here. That is a separate mold. You know, while we're in it, let's go ahead and look into this LED cob assembly here. I doubt it's a board in here. It's probably just the LEDs. Yep, it's actually pretty nice looking the way it goes up to the spotlight as well. It's actually an additional aluminum heat sink. It does have a little bit of thermal heat transfer compound on there in between the two. It is better than some you see. Maybe not the best heat sink, but there is some there to help dissipate. We'll look at the little spotlight or flashlight LED here as well. It's pretty nice. Just going to go ahead and put this back together, that way we can focus on the testing. I'm just going to go ahead and plug this back up. Make sure it's all functional. Yep. Charge it back up to fully charged. Our charge indicator level is actually pretty nice. I have taken these JST type connectors and made some little leads here where I can either put these in line to check current, or I can take this and hook it up to the battery and actually go to my new load tester here. So I have 10 the wires, so it should get as good a connection as we can. These wires are small and I realize that, but I'm going to do a low current drain just for that reason. I'm showing here that I got the current set for 1 amp, 2.7 volts cutoff, so it won't go below that, and no time discharge. So you can do a time discharge where you select the time you want to discharge regardless of the level of cutoff voltage. We're just going to know the full capacity because everything is zeroed out. This is the first time I'm using this meter, but I do like it so far. The display in the user interface is a lot better. We're reading 4.14 volts, and let's start the test. And we're reading right at 4 volts at 1 amp. It's even got Bluetooth, but I don't have that working yet. My phone has an issue with the app, but I'm just going to put this battery over here so the leads won't pull across the fan. Separate them out. I'm going to take this external thermistor and just put it under the battery. But at 1 amp we really shouldn't rise in temperature. Make sure we keep our wires away from the fan in case it does have to come on. And here's a still shot of what the display looks like. It's really a nice display here. The camera don't show it quite as well as it is in person. And now back, almost 3 hours into the test, this is what we're looking like. If you notice here, it even gives us our milliohm reading of the battery, which you got to consider the wiring here too, of course, but that's still fairly low, showing 555 milliohms. Back here now, 3 hours and almost 40 minutes and 3665 milliamp hours. Still got almost 3.4 volts on the battery, so it's looking pretty promising. We'll come back when it's done. Alright, back now. We are complete. 4 hours and almost 11 minutes, and capacity hit right at 4200 milliamp hours, or 4.2 amp hours. So I'm actually pretty impressed with that. It charged up to 4.15 volts on its own. I'm going to assume the cutoff voltage is 2.7. We'll check that later actually. So we're just going to charge it back up here after we run it down with the load tester, and we'll be back and check the current of the lights. So here we are, we're almost completely charged. We'll be right back when it's charged. So back now, we are fully charged. We can disconnect our USB-C cable. I'm going to disconnect the battery again, and I'm going to hook this up as an inline check. So I got both of my JST connectors here, male and female. I'm just going to use some Wago lever nuts here and connect these so I can easily take my meter and put in series with it for checking current. Let's bring over this Kaiweets digital meter here. I'm going to go ahead and get 2 more lever nuts so I can hook the meter up without getting clips. This will probably be a better connection than using alligator clips, honestly. Yeah, let's try the milliamp range. I think it looks like it goes up to 600 milliamps, which is kind of high for a milliamp range. So I know some modes of the light probably won't be above that, but let's just see. If it shoots above 600, I'll just take it to the amps jack. Alright, everything's connected. That looks good. Let's cut it on. Yep, we did overrange it. Let's go to amps. Yep, amps mode. Let's check it again. It's probably just over the range, but yeah, it did go over 600. So yep, 0.6. Yeah, it's dropping a little bit. So right at 0.6 amps. So that's with both on. Now if we drop to our lowest mode, that's 0.18. Now it's interesting that in that mode at 0.18, we're talking about 24 hours of runtime at 4.2 amp hours. Now if we go to the single LED, I'm calling it the third mode, we actually get a little bit higher current than both on together, about 0.65 on each. And then if we hold the button down, it should go to spotlight or flashlight mode, and we're about a half an amp. So about 500 milliamps on that. And of course we got our SOS. So that means when we first cut it on, we can get about 6.4 hours of use out of that mode. The second mode, where they're both on but dim, was 0.18, so that will be 24 hours. And then the spotlight is about 500 milliamps, so you're talking about basically 8.4 hours, so that's pretty good. And this board felt a little bit warm when I stuck my finger across it, and the battery right here's got a warm spot too, and I'll show that with the thermal imaging because I know you can't tell. So one minor concern is I'm getting about 120 degrees Fahrenheit, which isn't terrible. I just felt it warm to the touch there, and it's actually warmer than the light itself, so the heat sinks pretty good on the LED. And the battery, as you see here, it's got a little strip. I don't know if that's a small wire or a bad connection, but it's just heating up a little bit, so it might be worth our time to look into that. I'm going to show the reassembly of this light in the upper left hand corner just so you see that it went back together okay. But I'm going to take this time in the video and insert a part where I'm going to cut into the battery and just see if we can show why we was getting that little bit of a warm spot on the battery. We're going to cut this heat shrink and I'll tape it back up later. But yeah, it's not a connection issue or a small wire like I was just wondering about. It's actually a board, so okay, it must be a MOSFET. Let's take a closer look at this. Yeah, let me unplug it and we'll take a closer look. So yeah, we actually have two MOSFETs and another 6-pin chip. So these MOSFETs are 8205A, which are dual 5 amp N-channel MOSFETs. And we also have a DW01, which is a pretty common battery management chip. It's a 1 amp battery management chip. So that's one reason it was a little warm spot there, the MOSFETs themselves. So I'm just going to put some heavy duty packaging tape across the heat shrink and make it like it wasn't even here. Good as new, kinda. So another thing I want to take time to show here is if my phone is show like charging rapidly using the actual USB output. So this is my Pixel phone and it is showing charging rapidly. I'm making sure I'm using the Pixel cable here, so if it was any issue it wouldn't be the cable. We're showing like 4.8 volts at the moment and like 0.8 amps, and I believe the specs call this to be up to 1.5 amps rated. So here I'm just showing the cutoff voltage. So how good is the BMS at cutting the pack off at the right voltage level? And yep, right at 2.7, just below 2.7 volts. Fantastic. So all in all, this is a well-designed light. I thought it was interesting just how flexible and versatile it is, especially with the mounting. So that's some positives, as well as the long life. The USB power bank's a plus. I did like the silicone wires, and I like the USB-C charging cable instead of the old USB micro. On the things that I would change about it would be, you know, internal battery can be bad for a light. A swappable battery would be better if I had to choose. You know, let me know what your thoughts are in the comments as well when it comes to a backup light or a work light. You know, I would definitely look at that heat buildup on the pack and the board, make sure that's within range. It's probably well within operating temperature, but it's getting a little warm. And you know, we don't have a really good like indicator of when it's actually going to stop working on us. So the 25% LED does flash anytime it gets below like 3.4 volts. It starts going like 25%. So you don't, the problem with that is you don't get a really good idea of when it's actually going to stop working on you, you know, just watching the light, because the light blinks for quite a while. All those are minor things, I believe, but they are improvements. If there's any other ideas you might have that will make it a better light, please feel free to leave it in the comments below. And again, I'll have an update on this in the next 6 months to a year, as I know how well the battery is holding up in storage or on standby. ANCEL has agreed to give us a discount code. The discount code is ThriftyTool, and it's valid until August the 31st, 2022. So I hope you found this video helpful. I hope you found the look inside interesting. And if nothing else, you get to see what makes this light tick and the build and quality of the construction, so you can determine whether it's worth the purchase on your own. Hopefully we pointed out some good things as well as some things that can be improved on. And I do appreciate ANCEL for agreeing to send it to us and having us look inside of it. So thank you so much for your support. Please like, share, subscribe, Thanks for watching, and God bless.